Okay, so we are continuing our 10-5 notes. Last time we ended on the limit comparison test. So one more test, and that is it. We've had all our different tests. We've had nth term test, ratio, direct comparison, limit comparison, integral. I think that's it. Yep, so this one works for alternating series. So most of our tests, our terms had to be positive. With the alternating series test, we're going to alternate back and forth between positive and negative, positive and negative. So an alternating series, u sub n just being any term, we start positive, go negative, positive to negative. And it would just keep going forever. So our terms alternate back and forth between positive and negative. And this test is actually a pretty simple one, thank goodness, because some of them are not so simple.
Could it be the opposite? So could it be like a negative u to the 1 plus u to the 2?
According to the test, it's, well, let's try.
You can just move on if that's a weird question.
I am not 100% sure.
It appears in the homework.
But no, it should, on the homework, it should always start positive. I mean, all you could do to fix that is change where you start at. You can always make it start out positive, even if it's not starting out positive already. But the test only talks about when it starts out positive, so I won't say that it works if it starts out negative, because this is what the test says. So, okay. So it works if each u sub n, ignoring this part here. So u sub n doesn't include that stuff, that negative part. If each u sub n on its own is positive. So ignoring the factor part that makes it alternate. If the term preceding that, so u sub n is bigger than u sub n plus 1. The previous term is bigger than the next term. Has to go in descending order, get smaller. That's just saying the numbers get smaller. And the limit, again ignoring the alternating part of the terms, equals 0.
Does it have to fit all 3 of those scenarios?
It must fit all 3 for it to converge. If one of those doesn't work, it does not converge. Or at least we can't tell it converges by this test. So let's take a look at this series. This series also has a special name. It's called the alternating harmonic series. It goes back and forth from positive to negative. But remember the P series that was just 1 over n diverged, but it diverged so slowly it got its own name. The harmonic series is the one where last time we talked about within, it took like I don't remember if it was thousands or hundreds of thousands of terms, hundreds of millions of terms to just get bigger than 20. I diverged so slowly.
Not how to do that. What is your eye, okay.
I go to the eye doctor tomorrow. Most people say they think it's a popped blood vessel, and it doesn't hurt, so
Because every time you open the door, I can see it.
it is just kind of creepy.
I haven't seen it, so I watch. So, see, there's.
Oh. I'll
We're on
try.
the other side,
I've got
I
a
don't
face
see it.
the same.
Oh,
Yeah.
it's a pop
Okay,
blood
because
vessel.
normally you're on that.
It's a specific
Yes.
disease only math teachers get. It's called matharitis. Deadly in
We
50%
better all
of
stop
cases.
now doing math, just in case.
Watch and prison the groove, just didn't say it.
Her eyes are gonna start bleeding out, next thing you know, she's not gonna be able to move.
Dude, just.
Stop
It's really contagious.
Is it recording through this?
It is. So, if we were to actually write the terms out, we'd have 1 minus a half plus a third minus a fourth. Blah, blah, blah. Keeps going. So again, looking at it without the alternating piece, without this -1 part, would all our terms be positive if we were to take out that alternating part only? We just have 1 plus 1/2 plus 1/3 plus 1/4. So the alternating part is the only thing giving us negatives, and not the n is giving us negatives. So the alternating part, taken out, we have all positive terms. So we're good there. Then we have to check, is the term before going to be bigger than the next term? Is 1 bigger than 1/2? Which is bigger than 1/3, bigger than 1/4. Is that always going to be true? Then the last thing we have to check is the limit of, as n approaches infinity, of the series without the alternating piece. So of 1/n, will that converge to 0? So what are we going to get if we plug in infinity? 0. So all three things check out. We have positive terms only.
I don't like you.
Our terms keep getting smaller, and our terms are approaching 0. Again, if these terms approach something other than 0, if they approach 1, we wouldn't be adding smaller and smaller pieces, so it wouldn't converge. That's why it needs to approach 0. So this converges. The alternating harmonic series converges.
Actually, no. I would like to have a seat change.
You'll be okay.
You can do that.
Eliana only bites occasionally, so just deal with
When
it.
it is, it's hard, so. I mean, there isn't any seats in this
So
room.
if it is an alternating harmonic, then it converges.
Yep, so alternating harmonic converges, but harmonic diverges. So, one of our earlier questions that we had not addressed yet is, what do we really mean by absolute convergence? So this is where absolute versus conditional convergence really comes into play, is when we have these alternating series. So we have two options. If some series and the absolute value of the series converges, then we call that converging absolutely. A sub n converges absolutely. If the series A sub n converges and the absolute value of the series diverges, then the series converges conditionally. So, conditionally. If all our terms are already positive, we're either going to converge or diverge. It doesn't matter if we absolute value it because it's not going to change our series by taking the absolute value of a positive series. This really applies to our series that have negatives involved. So these alternating series are really affected by this absolute versus conditional convergence. So we're going to take another look at that alternating harmonic series. I just got an update, and I think it's been screwing with my smartboard. The alternating harmonic series converge absolutely or conditionally. So we just proved what happens with this series when it's not absolute value. What did we say happens to this series in example 3? It converges. So we already know this converges. Now we've got to check the absolute value of this series. So what's the absolute value going to do to this? Take out that -1, and really we just have the series 1 over n. And what do we know about 1 over n? It diverges because it's the harmonic series. So do we say this converges absolutely, or do we say this converges conditionally? Conditionally. This would converge conditionally. If we took any other p-series and made it an alternating p-series, -1 to the n plus 1 over n squared, that would converge absolutely because the alternating series would converge and the absolute value of that alternating series would also converge. And there is more to it, but it's not really necessary for calculus. There's more to why we care if it converges conditionally or absolutely. I felt like it might be more confusing to try and explain the extra stuff that's not going to be seen on the AP test. If you want me to talk about it, I can talk about it after the AP test, where we're just exploring interest topics. But I think because whenever I heard this, I'm like, well, who cares if it converges absolutely? It doesn't make a difference. But it does make a difference in terms of understanding series completely if you were ever to take series even more in depth than we're going to in this calculus. So it's good to know about, but it's not really useful until the next level of math, which happens a lot in math. So you're going to have about 35 minutes to work today.
Oh.
We have some extra
Yeah.
time to work today since we were in the middle of a lecture.
I didn't know it was an end.
Yeah,
It was like not even a page.
but I didn't feel like adding a topic on top of what we were already talking about, so.
I just put my assignments and draw a picture instead.
So page 528, 17 through 22, and 27 through 32. Some are just more practice on identifying if a series converges or diverges, and some are the tell if it converges conditionally or absolutely.
So,
Buttons.
Are you ready to look?